Hey everyone, welcome back to another Leetcode video. So in this video we are going to solve a daily problem which is June 1 2023. So the problem name is shortest path in a binary matrix. So from the problem name we can see that it's mentioned as path. So when any problem is mentioned as path, we'll be certain to know that if a problem has the name path, we will keep in mind that this problem can be reduced to DFS or BFS or recursion or backtracking. This type of mainly DFS and BFS is used in these type of problems. Okay, so in these types of problems DFS BFS are used. Okay, so this is how we are going to resolve this problem too, and we keep in mind that this problem can be reduced to DFS BFS. So we can also see that it's mentioned as shortest, right? Shortest path in binary matrix. So when it's said that shortest path, we could be certain that we can use BFS in this problem. Okay, so let's read the description and decide if choosing BFS was correct for us. So given n into n binary matrix grid, return the length of the shortest clear path in the matrix. There is no clear path, return -1. So it said that given a binary matrix, when it's mentioned at binary, so we can see that the values can be either 0 or either 1, and it's given a grid and we need to find the shortest clear path. Let's continue reading. So it says that we start from the top left cell which is 0 0, and we go to the bottom right cell which is the n-1 total row size and total column size, as it will be always n into n. So n-1 such that all the visited cells of the path are 0 and all the adjacent cells of the path are 8 directionally connected and they share an edge or a corner. Okay, the length of a clear path is the number of visited cells of this path. Okay, so it says that the cells that we can traverse are are mentioned as 0. So if a cell has 0 value, we can traverse into that cell. If a cell has 1, we cannot traverse into that cell. Okay, so if this is 1, so we cannot go there, we cannot go here. So what we can do, from this cell we can go to this cell, and when we are in this cell we see that this is the bottom right cell. So we have reached our target. So what will be the answer in this case? We have in this case the first cell we traverse it, we count it for 1, then for second cell we count it for 2. So the total clear path length will be 2. In this case the answer will be 2. So let's understand what it says by 8 directionally connected. So in the 8 directionally connected, we in this type of graph problem, in BFS DFS graph traversing problem, path problem, which is actually in a matrix form, and we want to reduce that matrix to actual graph problem, we use directions, and the directions are the directions left, right, top, down, that we can go. Usually the problems have directions mainly right, left, top and bottom, mainly have 4 directions, but in this problem they say that it will have 8 directions. Sorry, I haven't showed this direction, I need to draw it. Let's draw that. So we can see that these are the 8 directions. Usually we have the 4 directions, and now we have the 8 directions using the diagonal directions. So in this coordinate system, this is the x direct coordinate and this is the y coordinate, and you have studied in math class that in the positive x direction is this direction is positive, and this direction is the x prime which is negative, and this direction for y is positive and the y prime direction is negative. Okay, similar for other cases. So if we try to figure out what the direction will be, so this direction will be actually it will be 1 for x, and we don't have any y component, so it will be 1 0. Then for this part we have gone down and we have gone right, so it will be 1 for x but minus 1 for y because it's went down. Then for this direction we don't have any x component, so the x component will be 0, but we have y component, so we have gone down, so this will be 0 minus 1. For this we will be we have gone left, so the x component will be minus 1 and the y component will be also minus 1. Okay, so the y component will be also minus 1. And for this part we can see we have gone left but we don't have any y component, so this will be minus 1 and 0. Okay, minus 1 0. Then for here we have gone left and we have gone up, so our x component will be minus 1 as we have gone left, but we have gone up, so our y component will be 1. Okay, so then for this one we have gone up but we don't have any x component, so x will be 0 and y will be 1. Then for here we have gone up and we have gone right, so our x component will be 1 and our y component will be 1. So we have found the directions that we are going to go from an array. Let's think about it as an array. Okay, so think this is an array box. This is an array box. Think this is an array box. So from here we can go to other arrays, right? So we can go to this array which is on the right, which is on the diagonal, or we can go this one, or we can go this directional diagonal, or we can go this one, or we can go this diagonal direction, or we can go this bottom one, or we can go this right direction. So using this we can actually show that from this node we can go either right, we can go directionally, we can go up, we can go this node in this cell, we can go in the left cell, we can go this one cell, or we can go this one, or we can go this one. Sorry, I'm actually explaining in detail so that everyone can understand. If you already know this part, you can skip this video or skip this part. Okay, so now we know how we are traversing, so let's go into an example. So here we have an example where the grids have 0 and 1. So for 1 we can actually mark them as here. So 1 the cells that have 1 value they are blocked and they cannot be they cannot be visited, so we can only visit 0. So we can modify this diagram and see here. So the topmost corner it is 0 0 and the bottom right corner bottom right corner is 4 4. So we actually start from here. We are actually here and we start from here. Then we're actually here. Then we can go, we have two options. So how we are going to use it? We need to use, in this case, in this BFS and DFS we are going to use BFS. So in this BFS case we will be using a queue. So this is our queue. In the queue is queue's top is here and this is the bottom. So queue actually pops from the top. So in the queue we actually first have this 0 0 value. So we will first insert 0 and 0 in this queue. So at first we'll have 0, the queue top value will be 0. Then when we are trying to iterate, we are trying to see until the queue is empty. So we will pop this value and see which directions we can go. So from 0 0 we can go to right or any direction. So from 0 0 we can go to either right or either down. We cannot go to this diagonal direction or any other directions because they will be out of bound, right? We cannot go to any other directions because they will be out of bound. So we cannot go this direction because this cell value is not this cell's value is not 0, it has 1. We cannot go out of the bound, so we cannot follow these directions as well. We only need to follow these and these directions. Okay, so yeah, next we can go to this direction or this direction. So we have potential next direction, so we will be putting those rows and columns into our queue. So our queue will have 0 and 1. Then we will also insert 1 and 0. So these two new cells we have, and as we have already used this cell, the cell 0 0, we will pop it from the queue. So now our queue top is in here. So our queue top is in 0 1. So we are currently in this one. Now we have to do, let's just remove this. So from here we can go to this direction or we can go this direction. We cannot go top or this direction diagonally or this diagonally. We can go, yeah, we cannot go this direction or we cannot go this direction, but we can also go this diagonally, right? Okay, so we can see that from here which directions we can go. We can go to 0 2, this is 0 2 and 0 2, this path cell is 0 2 and this path cell is 0 0 and this cell is 1 0. Okay, we can see here. So from here we will be inserting them in our queue. Now what we can see here, that we have repeating problem. So when I was solving this problem, I need to figure out how I can fix this issue. You can see when we are traversing, we are iterating for this cell, we can see the cell 0 0 and cell 0 1 or 1 0 is coming again, and we have already visited them. If we add them again and again, there will be a loop. Okay, so we somehow need to break that loop. How we can break that loop? So there are two approaches. One is we can keep a visited count, and another is we can actually update the grid value. Okay, so first I will show you this way, then you can easily use the visited way. Okay, so updating the grid. So when we have traversed this cell, when we have traversed 0 0, we will update its value. At first we will be, this is the start, so this will be 1. Okay, then we are iterating for cell this cell, we are iterating for this cell. So we will be updating its its cell value as well. Before we add them, let's just remove them, and adding them, we will be updating its cell value. Its cell value will be 2, and also its cell value will be 2. When we are iterating for grid 0, we will be updating these cell values, these distances, and putting them to queue. So we can see from here that this grid, when we are iterating for this grid, we see that we have in next option we can go there. In next option we can go in this cell, but we cannot go to this cell or we cannot go to this cell, because they don't have 0. The values are not 0, value not equal 0, this value not equal 0. So this way we can actually check for the already visited nodes. So we will not insert here, so we will not insert this, or we will not insert this, right? So we will be having only with 0 2. So our 0 1 will be popped, and now we have 1 0 in our top. So in our top we have 1 0. So for 1 0, when we are in 1 0, let me remove all of these. So yeah, I should have leave this 1, this is 2, this is 2. So now we are in this node, this cell, which is 1 0. We are in this cell currently. Yeah, so we are in this cell. We can move here, we cannot move to other directions, like we cannot move there, we cannot move left, we cannot move top, we cannot move in this direction, we cannot go out of bound, we cannot go there, this cell, and we cannot go out of bound. So we have only option to choose, and that's this direction, this cell, and for this cell we will be adding it to the queue. So what we'll be adding, this cell is 2 0. Okay, so we will be adding 2 0 in our queue. And when we can see that this is our neighbor and we can add, we will be updating the distance, so we will be adding this to 3. Okay, so this is how we can use. Next, this will be popped. Sorry, I'm just removing them. So this will be 2. So now this will be popped. We can see from here we will be popped. The 10 will be popped. Next we have in queue top is this. We have queue top is 02, which is this cell. So in this cell we can see, let's just check here. So in this cell we can see, oh, when we added this, we should also be adding this to 3. So this should be 3 initially we added. So yeah, now we cannot go to any of the direction. We cannot go to this direction, we cannot go up, we cannot go left, we cannot go we cannot go down, we cannot go any of the directions, right? So we cannot go any of the directions. So here, and this cell is not the bottom right cell, so we don't continue it. Okay, so we don't continue and we just remove this. We remove this. Now what we have in the cell, we have this cell. So from here we will also add this direction. So we can go to this here, we can go to this here. So we can go to, we can go here or we can go here. So we will be updating it to 4 and 4. Next we try to iterate. So for so we will be adding that to queue. So from here we can go there. So this will be 5. So then from 5 we cannot go anywhere. So from next we can go from here to from here to here, which will be 5. And now it's kind of straightforward. We can go to 6. Then from here we can go either here or we can go either here. So we these are the 7. Then from let's go to the best case. So 7, from 7 we can go to here 8. Then from 8 we can go here, we can go here, or we can go here. So from 8, this is the 9, this is the 9, and this is 9. So our final length will be 9. Okay, this is how, so we have reached this portion, and this is how we will be keeping track of the visited nodes, and we will be traversing the array. This is basically a BFS solution, and this is basically a BFS traversal. We can also use DFS here, but I think BFS is more suitable in terms of shortest case, because BFS is like a level order traversing and DFS is not a level order traversing. Basically it goes from it goes deep into a node and traverses it before then it goes to another node. Then after traversing that node, it goes to traverse another node. So DFS is not not a good option in this case. We will be using BFS. So I think you understood this solution. When we want to use the visited, we have used updating the grid. We can also use the visited count, visited option. In that option we will be, when we are using visited, we will need to store another value, which is this distance in our queue. So in this case we will be storing the visited count, which is for 20 it will be 3. So we will be storing the distance here also in the queue, right? We will be storing in the queue. That's very straightforward. I think you can figure it out. Let's go to our problem solution. Let's go. So here's the straightforward solution. We first take the grid values. Here you can see the grid values are taken. Then what we can do, then we are first checking if the first cell is 0 or not, and in the last if it's reachable or not. If the target is not 0, which is the target, if the target is not 0, then we will return -1, because target is not reachable, or the initial starting point is not reachable. Then we are using this queue, and we are using this int array in this queue, and we will be using array dequeue. Then we have directions, and as I have mentioned, the directions all in the options. Then we add the queue, in the queue the first cell, and we update its value to 1 as it's visited, and its distance is initially 1. Then we take the current from the queue. We use queue.poll, Okay, we will use queue offer and queue poll. We can also use queue add and queue remove. We have used queue offer because it's thread safe, and initially advanced programmers use queue offer and queue poll. Then we can take the row and column from here, and we can take the distance from the grid, and from here we check if this row and column is the target or not. Then we return the distance. We have found our answer. Otherwise we will be traversing for its neighbors. So the neighbors are the directions that we can traverse. So neighbor row and neighbor column, we first check if this is bounded. If we see this function, if we see this is bound, if we can see this is bound, we can see that is bound has row greater than or equal 0 and row less than or equal less than row. Then this way we will determine if this is bound. If this is not bound, if this returns false, then the loop then the condition will break and go to this for loop again. If this is possible, if this is bound, then only then we are checking for the grid and the new column and new row and new column, and see if that value is 0. If that is 0, then we will be putting it to our queue as I've shown there, and we will be updating that cells distance. This is what I was doing, that I was updating the cells distance at first. If this way we are actually proceeding, and if the if even after this way we cannot reach our destination, we will be returning -1 because the queue will be empty. There is no way we can break the walls and we can go. So let's run this. You can see this is really fast and really efficient. So how let me show you how we can use the visited and solve this. So here's the solution with visited. So we have used a boolean array which is stored in visited, and we have initialized it to row and column. So we'll be determining visited for each row and column. So all of them are same. Then when initially we used this, but now we will be using this to store the visited. So firstly we have used the first cell, which is 0 0 to visited, so it's true. Then we are iterating the same way. Now we have said that initially the distance was in grid, but now we will be keeping the distance in the queue. So you can see from here that this is the distance. Initially it will be 1. So this is the distance how we can get it. Then for each directions we can go for each bound, and then look for the visited. If this is not visited and this also has 0, if this also has 0, then we will offer it in the queue, and we will be marking it as visited. You can see initially previously we have updated that cell value to distance +1. Now we are not updating it. We are just keeping the cell value, because this is important, because sometimes our cell value can be important. So for that case we will need the visited, and that's why we are storing the visited in a separate array, and that's how we can calculate. So this is how this can be used. Let's run it and check what happens. That's fine. We can see it's little bit efficient, and the memory limit is more. So and previously what was happening, previously our updating solution had like 98%, and the memory limit wasn't that fast. So they are the same. I think this video was helpful. If this video was helpful, please like, comment and subscribe to the channel for more Leetcode videos. Thank you.